Thank you, Val. Thank you, Jasper. Thank you, Carol, and welcome everybody. Good morning, and particularly to those online who can't join us today. So my name's Dan Hoare from the Broads Authority in the UK, and I've been involved with managing the delivery of Work Package 3 within the Canopé project, and the focus has been, as with Emil's talk, creating resilient peatlands. So in the Broads, we have an area that is rich with shallow lakes, surrounded by wetlands and peatlands, and the challenges we face in terms of restoring those to sustainable, resilient areas is ongoing. So this image I'm showing really just describes the vision in the Broads for how a sustainable peatland can be. So the Broads area, national park within the east of England, and the Broads Authority is responsible for managing that area, and that encompasses the nature conservation, thinking about biodiversity, but then also access and tourism and heritage and landscape features within that area. So that this diagram really brings all of that together in a nice convenient image, and gives us an idea of how the future could look, and then in which ways the interaction between landscape, ecology, and the visitor economy to the area, which is very important for tourism, all interact and generate what could be a vision of sustainability in that area. So we jump to an actual aerial photograph of the small lake we're talking about today. So Hickling Broad, it looks very familiar to some of the people from resident here in Friesland. We've got the shallow lake, we've got the drained marshes and the reed beds, but in Norfolk, where Hickling Broad is, in the Norfolk Broads, the North Sea is very close as well. So it's very close to the coast, and the site itself is, it's got every conservation designation going. So in terms of protection and value for biodiversity, it's within the national park area, site of special scientific interest, and is one of the series of Natura 2000 sites within the UK, and a Ramsar site as well. So it has that international designation for its habitats and species. Picture is slightly distorted on this view, but the image here just shows a focus in on the economy really, and the recreation. So we have there's the villages around, and the local economy is dependent on tourism. So that's people from all over the UK or even all over Europe, but also then people locally enjoying their recreation on the shallow lakes. So there's a lot of boat use, a lot of angling, people coming for bird watching and enjoying the nature conservation. So again, in terms of the recreation and economy, there's the sailing club, there's a windsurfing club, the boat storage and boat yards, all of which employ people. Paddle boarding now is very popular. There's pubs and facilities for access to the water. So all of these multiple uses combine in one site at Hickling Broad. And the Broads Authority's role is primarily in managing the navigation through the lake. And because it's a shallow lake, it likes to fill up. Part of the natural process is the sediment accumulates. So one of the challenges we have, and this map here shows the bathymetry of the lake, and the sort of central channel you can see is where that channel is maintained and dredged to allow the boat access from the village through to the wider navigable system in the Broads, which is 125 miles of navigation, and it's all tidal as well, so it's all connected to the sea. So all of this area requires management for the waterways access to continue. So in terms of the map here, the blue areas are the deeper areas and the red areas are the shallow areas. So in terms of where boats can access, or boats with the deeper, bigger boats can access, it is restricted to the main channel where it's managed. So if we zoom out slightly, so Hickling Broad is in a wider river system, so it's all connected by waterways. And when we were first looking at this project, well, what do we need to do in the Upper Thurn area to maintain the economy and the visitor access? It was primarily about dredging. So removing that accumulated sediment through the area. So Hickling Broad is in the top left of the image, and so the channel through the middle of the Broad required dredging. But then there was other channels that had silted up, became shallow in other areas of the river, and Horsey Mere up in the top right of the image. And again, there was a large area there that required dredging to allow access to other moorings and other facilities for boat users. So that was a background of one of the challenges in the area. But the other challenge, as in Zuidlaardermeer, was the degradation of habitat over time. So the Broads aren't unique. They've experienced a lot of eutrophication, a lot of intensive uses in the catchment area with accumulation of sediment and nutrients within the water bodies, which has then had a negative impact on not only the water plants under the water, the macrophytes, but also the vegetation around the edges of the Broad, the lake, which have shrunk over time. So the reed beds had receded, had eroded, and this picture was from 1911, so over 100 years ago, and it shows that the gradient, shall we say, from more terrestrial reed bed through to reeds actually growing out into the lake, and then water plants submerged in the lake. So again, we went back to stakeholders. We have all of these challenges in the shallow lake area, in the wetlands, and what do people want was the sort of open question we asked. What can we do to mitigate some of the impacts on the economy, but also preserve the nature and the habitat value of the site? So we put everything on a map, everyone contributed. So there was discussion about creating islands to make areas more sheltered. There was discussion about actually creating new reed bed and zoning areas so that there was more shelter for wildlife, for the wild fowl, for the ducks and the geese that use the site in the winter. So we went through that process with our stakeholders in the area, which included landowners, people from the sailing groups and sailing clubs and the boat yards. So they knew we had this large volume of sediment to dredge. We also had these targets to meet Natura 2000 targets in terms of water quality and habitat quality. So we condensed all of the ideas together and came up with a project plan to create or recreate some reed bed areas in the Broad, which would increase the area of reed. So thinking about where we could place the dredge sediment to actually recreate land that was lost. So where the reed beds had eroded and disappeared, actually physically replace them where they were. So again, this called for a sort of technical engineering solution. And the design solution we came up with was to use geotextile bags to create a perimeter and fill those with sediment from the dredged areas, and actually create a 1 hectare reed bed which would take all of the sediment dredged from the waterway channels. So we engaged widely, we put the contract out, and we worked with some engineers from the Netherlands, and they came over and helped us with the design concepts and the engineering. And we are now at the sort of end stage of that construction project. So the timeline for the project started way back in 2018. And we had the initial site that was selected. So from all of those areas in Hickling Broad where we worked with stakeholders. And so this aerial image was an area where there used to be a reed bed here. This is a sort of big patch of open water now, but there was a reed bed there in the 1940s. So we have aerial images from 1946 that showed this was a reed bed area. And this was the area we selected. It was a good area to target because it was very shallow water, so it wasn't a optimal area for water plants. So in terms of replacing open water with a reed bed, we weren't losing highly valuable water plant habitat. It was also an area where we could actually create some shelter behind. So instead of making an island, we made a spit. So a sort of an area of reed bed that then sheltered land behind. So the first image then was after year 1. So we'd put the geotextile bags to create this perimeter really to contain all the sediment. So this was on the footprint of the old reed bed, and you can see there's still open water behind, next to the reed bed, that was going to be the sheltered area. So the area within the lagoon is 1 hectare, and the total volume of sediment to be placed in total is something like 26,000 cubic meters of sediment. So this was the aerial image after year 1.
Yeah.
And this was after year 2. So you can see we can filling some of the sediment into that lagoon area to create the reed bed area, on which we would then plant reeds to generate reed bed, as you see in the left of the image. So the important thing here then is about the techniques used. So we knew we had to dredge, but why could we not just put the sediment on some dry land or pump it further away? And we were looking at the options, and we've done other dredging projects in this area where we had put sediment on agricultural land and let it dry out and use that nutrient value on dry land so that the arable crops could benefit from that. You know, it's a bit of a circular use of the sediment and the nutrients back to a productive use for the adjacent agricultural landowners. But again, when we're thinking about carbon, all of that organic rich sediment, so it was peat material, and there's a lot of decayed plant matter and algae. So the spreading that on land and letting it dry out actually releases a large amount of carbon dioxide as that material oxidizes. So actually keeping the sediment wet, keeping it within the lake, was one way in which we could drive down our carbon emissions from this project. So keeping the sediment wet, keep wetlands wet, keep sediment wet is my motto here. And that's what we did on this site. So this was the end of year 2 of dredging. And then the final shot I have here is then after the main period of dredging, and you can just see this is earlier in the year. This was in April this year, and all of the area is pretty much filled with sediment now. Our staff are currently, all of this work was delivered by Broads Authority staff. We have the equipment and the machinery and the expertise to carry out these projects ourselves, which is really great when it comes to innovative designs and tackling these problems. So that's where we are now. So this is a site from sort of the level of the river, and you can see the excavator here putting material over on into the area to build up the perimeter for planting reeds. And so Marie-Pierre, our colleague here, who couldn't be here with us in person today, has been the chair of the steering group for Canopy. So here she is. This is what she's doing at the moment. She's directing the works out on site. So thank you, Marie-Pierre, for that. So the final construction phase, so you can see now this was an area of totally open water, and it's now got sediment. It's the water level is such that we can plant reeds and establish that vegetation over that 1 hectare area. And again, here's a more recent aerial photo, so you can see it's sort of drying out just on the surface. So this is only, say, 50 to 100 millimeters higher than the typical water level. And in terms of the lake as well, you can see in the water is quite clear. So Hickling Broad has had many decades of very poor water quality with high algal concentration, very low water clarity, high turbidity, and very few water plants. So you can see here there's some water plants. This was taken earlier in the season, and you can see the sort of darker patches in the open water where the water plants are growing. And this is, you can't quite see it, but the area of still water behind the reed bed, again, is full of water plants, and they're in a very sheltered area now. So yeah, this area here, the whole area, the project, we've called it Cara Bay. So the bay is the protected sheltered area of water at the back, and the Cara is the stonewort, the macrophyte. So Cara intermediate stonewort, is a species that only found in the UK, in Hickling Broad and some of these other areas that I showed on the map in the Upper Thurn area. So in terms of conservation, biodiversity value, the site is unique in the UK for the growth of this plant, and any measures to help protect that species. The impacts on it are poor water quality, and then also suspended sediment. So having an area that's protected from wind and waves is valuable for this species. Another challenge we faced during the course of the project then is the environment itself. The water in Hickling Broad is slightly brackish. I meant in the early slides there was the image of the North Sea being very close. The catchment area for the Broad is in close contact with the sea, so the water actually that comes through into the drainage channels around Hickling Broad is actually drawing in from the sea. So the brackish water leads us to having this algae, Primnesium. So Primnesium parvum is particularly grows in brackish water. So it's a flagellate algae that unfortunately has a toxic chemical within it that kills fish. So when the Primnesium algae blooms, we can also experience fish kills, which in terms of some of the recreation and tourism value of the area, angling, people coming to catch fish is a big part of the economy. So anything we can do to prevent any Primnesium outbreaks and fish kills. So what we did, we worked with a local company who were able to analyse for this, specifically for this species, using PCR tests. So when we started this, I'd never heard of a PCR test, but now everyone knows what a PCR test is. And yeah, we were targeting PCR to look for Primnesium because it's a very small algae. It's only, say, 5 microns. Previous counts were using light microscopy, and there's several other species that look very similar. So we were able to really get some very high quality, high specific data. And thankfully, during all of our works, so there was a lot of disturbance, so there's vessels back and forth, dredging sediment, some nutrient release, all of these things potentially could cause Primnesium and algal blooms. But what we showed through our constant monitoring over the whole period was that the Primnesium, the threshold at which, you know, the early warning stages for the density of the algae to have an impact was about 180,000 of these units of Primnesium counts per milliliter. So we only ever breached that once. You know, we were on standby then, but it was only at one site in the Broad, and that tailed off again. So Primnesium didn't have an outbreak during the works. So thinking about other projects within Canopy, we were looking then at the spatial distribution of what drives this Primnesium algae. So again, we were able to take those samples over a much wider area of the catchment. You can see in the top left, most of the high concentration of Primnesium was all focused in the sort of northwest corner of Hickling Broad, right where we were doing work, but this was through the whole period and has been a historic pattern through time. So you can see in other areas of the River Thurne system and Horsey Mere in the top right, much lower concentrations of Primnesium. It's present there all the time, all year round. So again, the research that we've been able and the data we've gathered through the Canopy project really is, we've got some next steps to move on to in terms of, well, you know, what are the factors driving Primnesium? The original fear was that the actual sediment disturbance would be the biggest driver. It hasn't been. It's something to do with water temperature, water quality. Again, I'm looking at Jasper and thinking there's links with your research and that doing multiple sampling across a lake, the spatial variation of water quality and all of those factors that drive the ecology is present in this lake as well. So we've got some commonality between the Canopy project sites. So as we're in the Broads anyway, very near the end of the project, we just now currently the team are out on site planting up the reeds, planting up vegetation onto that 1 hectare area. We have still some challenges ahead though. So the technical challenges we've faced during the course of this project is about efficiencies in dredging and actually finding reuse options. What are the least carbon expensive options for maintaining waterways? So I said about, do we put it to land? Do we create new habitat? All of this burns diesel and carbon during the construction, so we have to think about that carefully as well. The innovative design aspects, whilst it's great to think of different ways of doing things, they present their own challenges that we need to manage over time as well. So we're in this for the long haul. This isn't just the 3-4 years of the Canopy project. And then also the material used to create the area is highly variable. You have one area might be very organic rich, other areas may have more clay, so that brings in challenges for construction, for the engineering qualities. So environmentally, the challenges we've faced is, well, in terms of thinking about our greenhouse gas emissions, how do we reduce that? One of the measures we've brought in then is to use an alternative fuel. So HVO, hydrotreated vegetable oil, is a replacement for diesel. It comes from waste cooking oil, so is carbon neutral in that sense that it's come from biogenic sources rather than fossil diesel. High water levels, as I said, the Broads area is tidal. We've also then had different rainfall patterns in the last few years. So high water levels have actually hindered our progress in terms of the practical construction on site. We have a large population of geese as well. So this isn't wintering migrant geese. This is feral geese species that are resident all year round. So Canada geese, grey-lag geese, Egyptian geese, and they love to eat fresh plants. So in terms of establishment of the area, we are going to have to manage this ongoing. Talked about algal blooms. The geotextile as well, when we started this project, we were looking at the design solutions. Would it be steel? Would it be wood? Would it just be sediment? But to give it some stability, we needed some form of retention. So the geotextile is a plastic. We have introduced that to the environment, but it's now under sediment, so it's not going to degrade from UV. So we need to manage it so that that plastic stays in place for as long as possible. From a legislation point of view, in the UK, as with everywhere else in the EU, the legislation and legal frameworks within which we have to work for these types of projects is enormous. So we have to think about waste in terms of anything dredged is a waste, so sediment is a waste. The planning permission required and the flood risk assessments, all of these considerations, you need a specialist team just to get you through these projects. So if you're a small landowner looking at sustainable or resilient ways to manage your wetland, a project on this scale, you're not going to do it by yourself unless you're very fortunate and can navigate your way through all of these areas. So it's not for the faint-hearted, and it needs those competent staff and the team behind me who have helped negotiate all of this. And then in terms of our societal challenges, when it was apparent when we had our stakeholder meetings, different user groups want different things. So often the one thing they want is directly opposite to what the other group wants. So how do you balance that? So this is where the Broads Authority's role was to help weave a way through and design a project that gave everyone something of what they wanted. So thinking of the maintenance of the waterways, we dredged that area, we've increased the habitat, and we have now created this. So questions I know at the end, but thank you for listening. Thank you, Jasper.